Hi everyone, in this video we're going to be creating a confidence interval for two samples where we're comparing the mean between two, or the means between two different samples. We've done this before, but we found proportions when we took our sample. This time we're going to be finding means or averages. So which cookie has the most chips? We're going to be counting chocolate chips. Well, we're going to be pretending to count chocolate chips. In Chips Ahoy cookies versus something called Chipsters. But as you're looking at your notes, you might want to add this to the top, confidence intervals for a difference in means. So you have a better idea about what this note sheet is covering. So we've created confidence intervals for a difference in proportions, like I mentioned, but today we're going to be using kind of the formulas we've been using in recent classes to do the same thing for means. So if you want to get some highlighters, I'm going to kind of just highlight Gary's sample. Gary takes a random sample of 35. Chips Ahoy counts the chocolate chips. He gets a mean of 21.56 chocolate chips with a standard deviation of 2.49. Different color for Emily. She's sampling 32 Chipsters, sample of 18, and standard deviation. So again, when we create these confidence intervals, we're going to be looking for whether or not there's a difference. We've already sort of talked about containing an interval that contains 0 versus an interval that doesn't contain 0. But we get to look at that again today with this example. It's just that some of the formulas to get there are going to be a little bit different from last class. So let's first start by getting organized. You might want to pause the video and just jot down everything that's in that top section where it says get organized. So the Chips Ahoy mean and standard deviation, the Chipsters mean and standard deviation, and then go ahead and calculate the difference. We're going to do Chips Ahoy minus Chipsters so we can all stay together with our work. We could subtract the other way around, but let's all do it the same way, starting with Chips Ahoy minus Chipsters. So go ahead, pause the video, and take care of that. Okay, this is sort of what your notes should look like so far. When you start to move down to part 2, I don't really have too much to say about that section either because you know the 3 conditions that you have to check. The only thing I was going to pop in and say is that make sure you're checking all 3 conditions for both samples. Let's also talk about how when we name this procedure, we're going to be calling it a 2 sample. We're still using means, so we're still going to use that t-curve, but it's for the difference in means. So go ahead and jot down 2 sample t-interval for the difference in these means, and then take a couple minutes and pause the video. Let's try and get the conditions checked for Gary's sample and Emily's sample. Okay. It's stated that both of them are random. We're looking at probably millions, billions of cookies that have ever been processed and made, or at least processed and made right now. So we're definitely safe with the 10% condition. And then luckily, we didn't have to worry about looking at a sample graph or anything like that because both of the samples were at least 30. So again, what that means is our sampling distribution is going to be a t-curve because we're still using these sample standard deviations instead of the population standard deviation. We don't know the true population standard deviation. We're stuck with these samples, so we're still going to end up with a t-curve, even though we have at least 30 in each sample. So I guess what I could scribble down here is that So again, the normal part of this like normal large sample is just saying, hey, what if our population was normal? If it states that, our sampling distribution, when we sample and estimate this population standard deviation with the sample standard deviation, even though it's coming from a normal population, we're still going to end up with that t-curve. That wasn't the case, so we checked to see if the sample was large enough, and it was. So since the large sample, or kind of going back to that CLT condition passes, our sampling distribution of the differences, will be a t-curve. It's important to know why you're checking these conditions because you're going to get multiple choice questions on the exam regarding that, so you might want to add that here. Okay. Says if Gary and Emily repeated this process many times and created a dot plot. So we're trying to look at the sampling distribution we just talked about. So this dot plot is kind of a simulated sampling distribution. Describe the shape. Okay, we just talked about it being a t-curve. So you could kind of draw an arrow from those notes to here, or kind of reemphasize this again for yourself if you're someone that likes to see it written a couple times. So I said it should be approximately normal, but because we're using, it's really because we're using this standard deviation as, we're using our sample standard deviation instead of the population standard deviation, we're going to get this t-curve. So we end up with something that's not approximately normal because we have much more variation. The center is just the difference that you came up with at the top of the paper. So if we take many, many, many samples, on average, we should see 3.34 as the difference in the number of chocolate chips. So we just took our sample result from the Chips Ahoy and subtracted that by the Chipster chips. Standard deviation is a little new. This is on the formula sheet. We haven't used this a ton, but it looks just like the kind of combination of when we did this with proportions. We're taking the big square root, and then we're using that kind of formula from one sample that we saw a couple classes ago to combine those. So really what we're doing here, again, we're saying it should be this, but we don't know what sigma is, so we're stuck using the standard deviation from the sample. Really what this is, when we square that standard deviation, we get the variance. Do the same thing for the second sample. Divide by the sample sizes, because we've really squared this bottom part too. That's why the radical goes away. But when we square these numerators to get back to the standard deviation, we have to square root that whole thing. So this is on your formula sheet. You can write it down here so you have it for your notes, but just know that's on your formula sheet for you. Okay, we're ready to get calculating. We checked our conditions. This part, this number 3, is just a little bit of an extra look for you guys at what the sampling distribution looks like when we talk about the differences. But once we've checked those conditions, we're ready to start calculating. So we know what our point estimate is. Let me go back up. This is going to end up being our point estimate, 3.334. We kind of have our standard error down here. We're just going to have to plug in the numbers. But to get a confidence interval, we always need that critical value. So we know we're using a t-curve, so we know we're going to use inverse t, but when you go to inverse t, it asks you for the area. So since this is going to be, let's go to the next page and see. There it is. Since this is going to be a 95% confidence interval, we're going to need to use 0.025 in the area, and it only asks for 1 degree of freedom. So we have 2 samples, they're different sizes, like what are we supposed to use? So jot down these notes at the top, please. For the degree of freedom, we're going to use the safer. Conservative just means we're playing it safe value. So take the smaller sample, because that's, worse. We always like bigger and bigger samples. So the safer value is to use the smaller sample and then subtract 1. So if you want to add this green part, I can't really split up my notes too much. Maybe we'll do that. If you want to add this green part, I'm going to use the sample that was only size 32. That was Emily. Gary took 35, but we're going to use Emily's. Drop down 32 to 31. We're using inverse t here. That gets us our critical value. So we had our point estimate. Now we have our critical value. Next, we're going to punch in all these numbers. If I were you, I'd pause the video, try it yourself, and then come back and see if your work matches mine. So here's that point estimate we talked about earlier, the critical value, and then here's how I plugged everything into the standard error formula. I got my margin of error to be about 1.839, so I added and subtracted that from our point estimate. So we think there's an average difference of anywhere between 1.5 chocolate chips to 5.179. Those kind of look like commas. That should be a decimal. So do we have convincing evidence of a difference? We've talked about this before, but 0 is not in my interval. If 0 was in there, we would think it's very plausible that there is no difference. But it looks as though Chips Ahoy probably has more, because when we subtract Chips Ahoy minus Chipsters, we always get a positive number in this confidence interval. So do we have convincing evidence of a difference? Yeah, we don't think that there isn't a difference. Yes, because 0 is not contained in the interval of plausible values. And I just mentioned, like I said here in pink, it appears Chips Ahoy has more because the entire interval is positive. So let's just summarize some of the new stuff down here at the bottom. This is new, 2 sample t interval for that difference in means. So let's make sure we add this here so we know how to name our procedure. This is not new. We already knew all of these conditions. Just know that we're going to have to check them for both samples now. The formula, kind of new. We know we start with the point estimate. We know we need to get that critical value. This formula looks a lot different, and remember, it's on your formula sheet. And then concluding, also not new. You've been doing that for quite a while now. So once you get all of these notes, please try the check your understanding on the next page. Then there are 3 multiple choice questions on the last page for you to practice. And when you're finished with all of that, go ahead and pick up the Chapter 10 Frappy. It's another really good practice problem for you to look at that comes from an old AP exam.